Hello everyone, I am Surendra Jain, Master Teacher in Vedantu. I am presenting you the solutions of JEE Advanced 2019. This is question number 1 from paper 2 from the topic matrices. One very important topic for JEE Advanced. In fact, this question that year was one of the most challenging problem of entire paper. I remember all the students were saying that this year matrices was very difficult. Let us see what this question is. Let P1, P2, P3, P4, P5, P6 are 6 3 into 3 matrices and X is sigma of Pk into 1 3 into 3 matrix into Pkt. Then we have to answer if X into 111 is equal to alpha into 111, then alpha is 30. B, X is symmetric matrix. C, sum of diagonal entries of X is 18. D, X minus 30i is an invertible matrix. So let us solve this question. First I will solve for B part to find X is symmetric or not. So let us take X transpose and let us write this as Pk into A into Pkt whole transpose. I am writing this matrix as A. So here by use of property of order reversal, when taking transpose over product of two or more matrices, this becomes Pkt T A transpose Pk transpose. Now Pk transpose, then again transpose will be Pk only, and we can check A is also symmetric. So A transpose will be A into Pk transpose. So we can check for this term, if we take transpose, we get same term back. So which means X transpose will give you X only. So this X is symmetric. So this part B is absolutely correct. Now coming to A part, which says X into 1 1 1. Now to solve this, I will write sigma of Pk into A into Pk transpose into 1 1 1. Okay, now please notice all the matrices P1 to P6 are such that 4 of them, P1, P2, P3 and P6, they are symmetric. So they are transpose of themselves. And P4 and P5 are such that they are transpose of each other. Which means if I consider this Pk transpose, okay, it will be giving us all these matrices only P1 to P6. Maybe in some different arrangement, but all these P1 to P6 only. Now, if we multiply this Pkt with 111, with the property this all Pk or Pkt have in every row 1 1 and 2 times 0. So if you multiply such row with this 111, we will always get product as 1 in each row. So Pk into A, and here we will be getting 1 1 1 only. Okay, now A and 1 1 1 can be considered as constant, so I can take them as common. So sigma Pk, I am putting it bracket here, and A into 1 1 1. Okay, so the sigma Pk will be 2 9 times, because we can check at every position of P1 to P6 we have 2 times 1 and 4 times 0. So their sum will be 2 2 at all 9 positions. And this product of A with 1 1 1, we can check first row of this A when multiplied with 1 1 1 will give us 6 here, will give 3 here, and it will give 6 here. And if we multiply these two matrices, we get 30 here, 30 here and 30 here. So we can take 30 common and we will get 1 1 1 here. So this option number A is absolutely correct. Okay, now I am coming to D part, because this D part is direct consequence of A part only. Let us see how. So in A part we proved that X into 1 1 1 is equal to 30 times 1 1 1. If I bring this 30 into 1 1 1 on the left hand side, it will become X minus 30i into 1 1 1, but I am writing this as small x y z equal to 0 0 0 on the right hand side. Why I am writing so? Because this can be seen as linear equation, linear homogeneous equation in XYZ, which has solutions to be x is equal to y equal to z equal to 1, which means non-zero solutions, which is possible only if determinant value of x minus 30i is equal to 0. Okay, so this means x minus 30i should be singular or it should be non-invertible. Okay, so in this D option, if we check, they have given x minus 30i to be invertible. That means D is the wrong option. Now coming to C part, which is asking the sum of diagonal entries of x, if it is 18 or not. Now we know this sum of diagonal elements of a square matrix is called as trace. And there is one very important property on trace which says trace of P into Q is equal to trace of Q into P. Even if PQ is not equal to QP, their traces are still the same. Okay, now I am going to use this property to find the sum of diagonal elements of x, that is trace of x, and we can write this as sigma of trace of pk into A into pkt. So I can take this A into pkt as one matrix and pk as another. So we can, using this, change their orders. So it will become trace of A into pkt into pk. Now there is one more important thing about this question. This pkt, if multiplied with pk, we can check, it will always give us I only. All the matrices are such that if you multiply them with their transpose, you will get I. So this means here this pkt into pk will become I, and A into I, we know this will be equal to A. So this becomes trace of A, and here k is varying from 1 to 6, and trace of A is 2 plus 1, that is 3. So this 3 should be added 6 times, k from 1 to 6. So this will become equal to 18. So answer of this question is definitely equal to 18. This is one method. I will tell you one more way of doing this, though it is not so obvious, but you can just think over it, that this expression pk into A into pkt, okay, if you multiply and let us say this becomes equal to B, you can check for all values of k, p1 to p6, this product will be such that if A has diagonal elements as d1, d2, d3, okay, then B will also have same 3 elements in its diagonal, may not be in same order, but in some other different order, you can say. Maybe it's some permutation d1, d2, d3, which means after multiplication, pre-multiplication with pk and post-multiplication with pkt, our diagonal elements will remain at diagonal element only. So for all such terms, their trace is going to be same as trace of A. So this trace of pk into A into pkt will be same as trace of A only. And this I have already used in my first method, so answer will remain 18. So answer for this question should be A, B and C. So this completes my solution of this question. I hope you liked this solution. Thank you so much and stay tuned for more solutions. Thank you. Bye.